everyone. I'm Abel Braaksma from Abel Consulting, talking here about the lazy processing of XML using XSLT 3. I'm going to talk a bit about large XML and the challenges that it has posed. The processing methods that we can use to process large XML sets. The lazy processing of XML, the subject of this talk, and how it compares performance. We've probably all come across the situation where you have like a big XML file, you try to process it and you run out of memory. In these situations, you're kind of out of luck unless you have another way of processing it. The typical other way is streaming, where you don't load the whole document at once in memory, but you just go over the whole document node by node. Another approach could be, oh, hold on, sorry. The streaming approach is relatively fast because it just goes over all the nodes. It has a constant low memory footprint, so that regardless the size of the document or regardless how long the feed will take, it will not increase the memory, so it could be using smaller devices. However, it has some limitations. Because you can only go once through the whole document, you can only select or process anything that is on the forward axis. As a result of this, it is quite hard to master and to use the expressive power that you're used to with normal DOM processing. With lazy loading, you would say, say you have this use XML document with a lot of text nodes or something. All these nodes, all these elements, you load at once as a structure, but you wouldn't load the text yet. That's one example of lazy loading, and only when you actually need these text nodes, you would get it from disk or from the resource, and you would load it in memory. This approach is typical in XML databases. It is used in XDB. I heard it was used in Exist. I'm not quite sure about MarkLogic, but maybe they have a similar approach. You have the power here with free-ranging expressions. You can go back and forth. So you don't have the limitation of only having to use the forward axis. However, it's not yet available in XSLT. Another approach of dealing with large data is succinct data structures. In the succinct data structure, you, instead of storing pointers to everything, or instead of loading the whole object in memory, you use a very specific bitwise format to make the memory footprint as low as possible. This allows you to load much larger documents and still gives you the possibility of using free-ranging expressions. However, it moves the problem forward, so you can load large documents, but you will run into the limit of not having enough memory at some point. A well-known, well, not sure how well-known, but an XML processor that uses succinct data structures is XML. At this moment, as far as I know, it's not updatable, which is why we cannot yet use it with XSLT. A very straightforward or easy way of dealing with large XML is simply compression. You could zip the whole thing and use some kind of on-the-fly decompression, perhaps. However, that means that each node will have to be compressed, decompressed all the time. It costs a lot of processing power. And if you were to have to decompress the whole tree, you still have the same problem that you run into. You still don't have enough memory for loading the whole document. So again, this one moves the problem forward, doesn't give you a good way of dealing with large data. So, in an ideal world, it would be nice to kind of combine all these approaches so that you have the power of streaming, so you don't load everything in memory at once. And you have the ability to use, I don't know, succinct data structures to have as little, that you use as little memory as possible for the parts that you do need. This approach to only load those parts that you want to use at a given moment, I'll call lazy processing, which is possible with XSLT. So let's revisit the type of processing methods that are available in XSLT. The classical approach, as you all know it when you work with XSLT, is a DOM approach. When you load an XML file, it creates an XDM in memory, and you have all the possibility to go back and forward through the document to select the nodes that you want and to output stuff you like. This is the default model for XSLT 1 and 2, and as far as I know, there's no, XSLT 1 and 2 don't give another way of processing. In XSLT 3, there's a new processing method, it's called streaming, which is just like I described, where you don't load anything except the current node in memory, and you keep only a memory of your ancestors. So the first approach is very versatile. You have a lot of expressive power. You can do anything that you used to do, and it is quite easy to master. The streaming approach, which loads everything on the fly, gives very limited expression power because you can still only move in the forward axis. You can't look back. You can't go to the previous sibling. It's not yet very well known, at least not with XSLT, because XSLT 3 is not yet there. However, people that have been using Saxon know that there's a streaming extension that you can use. But people that have used it have found out that it is quite hard to write a good style sheet that way. So let's look at the third method. Enter lazy processing. Lazy processing of XML. Let's combine streaming and the DOM together. The idea with this approach is that you have the expression power of the DOM, but you have the memory footprint of streaming. So you can use the expressive power that you used to with the DOM. So it's not that hard. And still you can load documents of any size. So how would that work? The current status of XSLT 3 is still in a working draft, but it gives quite some possibilities already to do this type of streaming, where you can combine streaming with access to certain nodes as a DOM object. To turn on streaming, all you have to do is create a mode, specify a mode, and set the streamable property, streamable attribute to yes. In this particular situation, that would make the default mode, the unnamed mode of the XSLT style sheet, streamable. So any input will be processed in a streaming manner. The XL mode, by the way, is a new instruction that you have, a new declaration. In XSLT 2, you would declare a mode on a template, and in XSLT 3, you can create a mode as a declaration and give it certain properties, like whether it's streaming or not. We'll see some other properties as well in a minute. So here's an extreme example. Suppose you have this huge document and you're only interested in, let's say, the creation date or the author or something that's available on the root node. Now, this isn't possible with XSLT2 when the document is too big and to fit in memory. But in XSLT3, you could say, stream it. When you match the root template, give me the creation date. It will still, however, go over the whole document because that's required. It must know whether everything is well formed, and it will have to find at some point the closing tag of the root node. Here's an extreme counter example. If your style sheet looks like this, you will process all the nodes of the document as text nodes, and you will output the text. With the strip space elements, I added that here for forcing the processor to have to process every text node so that I can use it later to do a comparison for performance. So the first example was we only are interested in one node. Here we want to do streaming on everything. Now, in most situations where you write the XSLT style sheet, you're probably only interested in a couple of elements. You don't need to go over everything. So, suppose we only want some data from the chapter. We want to see all the titles in the XML document. And everything else we can just discard. So the whole content of any chapter, all the paragraphs, all the images, the embedded SVGs, we just want to throw that away. Now, the thing of interest here is the attribute on no match. With deep skip, you tell the processor to skip the node that is not matched and to throw everything away. So here we are matching a chapter. Now anything that's not a chapter and all its children will be thrown away. Now, there is a bit of a problem with this style sheet. I wasn't very awake this morning, and I think I introduced the problem myself. Anybody see what would happen here? I mean, if you have any...
If the chapter is not a root, you will skip the document.
Okay, you were more awake than I was.
You will skip the document anyway, because the root is the document node.
Exactly. Like Roland is saying, deep skip says anything not matched will be skipped. Since we don't have a matching template for the root node, the whole document will be skipped.
Sufficient.
Be quick.
It will be very quick, yes. We have a variant of deep skip that's called shallow skip. Instead of throwing all children away, shallow skip will not throw anything away, will go through the whole tree, but it will not output the normal text that you see in XSLT2. So it will do nothing but process the children again. So in this situation, with shallow skip, at some point when it matches the chapter, it will output the titles. So this would be the solution for the previous problem. Now, let's revisit this lazy processing a little bit. Suppose we're only interested in employees by the name Charles. There's another new function in XSLT3 was specifically added for streaming. Regardless of the name, it actually does something else. With copy off, you break out of streaming. So you say, I'm in this node, this element, and I want to do normal DOM-style processing of that node. Copy off does exactly what its name says. It's like XSL copy off, but then you can use it in an expression which tells the processor that after this instruction, you're allowed to stop processing in streaming mode. This, switching the mode, is not allowed in a normal template. You can't do that. But when you have the copy off over there, processor knows that, hey, from this moment on, I have a DOM copy in XDM of the employee by the name of Charles. And you can do normal processing of that element. Now here is a similar example, however it's in line. So you see again the copy of instruction in the middle of the expression. And this allows us to write after this copy of instruction something that is not allowed in streaming. For instance, checking the child of author and person name to see if it matches John. It's not allowed in streaming because person name has to be normalized with all its children to find out whether it actually contains the text John. And that is not a streaming expression because after that it will have to go back to person name to do the rest of the expression. And here we are selecting two children, abstract and fiber. So the combination of this whole expression is streamable, and you're actually breaking out of streaming in the middle of it, selecting a subset of nodes, and in the subset of nodes you can do free-ranging expressions with all the power that you're used to from XSLT2. XSLT3 comes with a lot of more power to help us dealing with certain situations in streaming. Well, it's sort of copy of instruction. Copy of instruction takes a copy on that point and makes how do you say that in English? Disjoint copy. So there's no way to check for the ancestors. Snapshot does the same, but it keeps the ancestors. So if you are in employees/employee and you make a snapshot at that point, you are capable of checking the parent when you process these nodes. Iterate. It's a bit like for each, but it allows you to, inside the iteration loop, to change variables. And what's more, it allows you to break out of the loop. In for each you have to go over all the elements, which can be quite time consuming. But suppose we were looking for the same John, as in the previous example. When you find John, you can just bail out and stop processing. Merge is an instruction to make it possible to have, two documents or two nodes, to merge them together in a streaming way. Shallow skip we already saw, deep skip we saw. There's also shallow copy and deep copy. They do the reverse. The shallow copy works a bit like XSL copy, and deep copy works like XSL copy off. There's the extra instruction in XPath 3. It's called read lines, which allows you to read an external textual document in a streaming manner.
Unparsed text doesn't do that today?
Sorry?
Doesn't unparsed text do
No.
that today?
No, unparsed text will have...
Ingest it all in and then...
Exactly. And read lines takes it line by
I
line.
think MarkLogic's actually is streaming, but we'll take a look at it.
Alright. XL accumulator. It's a declaration on the root level in a style sheet. It gives you the ability to any node that goes through the streaming process, to give it an accumulator function, like calculating the sum of all the processed order items, so that at any given point, when you process these order items, it has the current the current sum of these sorry. I was distracted for a minute. I have 5 minutes left, so I'll skip the rest of the accumulator for now. Let's have a quick look at how this performs. So, what I did, I took all Shakespeare's work, and there's an XML version somewhere on the net, and I just combined them into one document, and I copied them over a couple of times, so I got significantly large documents. The first one here, the deep, it's like the first example. It only checks something on the root node and skips everything else. I put that in, not because it's like a real world example, but to make a good comparison. What happens if you totally skip everything? Or when you process a couple of nodes. Deep O2 does the same kind of deep skip, but it processes about 2% of the nodes, of the elements that are matched. Shallow does the same as the deep skip, but then it's shallow skip, so it forces the processor to go over all the nodes. It cannot simply just throw away all the children. Text is the default mode for XSLT2, where you output all the textual content of the element. To prevent it from tampering with the timings, I changed the text to output only a very little bit, so that catching all the outputs did not change the timings too much. Now, this is the classical in-memory approach with XSLT2 and the DOM. You'll see that deep and shallow skip don't give a real advantage. The reason is probably because the whole document is already in memory, so there's not a real reason, not a real performance improvement when you skip over items. Also, the difference between skipping over everything and outputting everything is only about 20 or 30% here. Now, with streaming, the graph looks quite different. Skipping over everything takes about 4 seconds on 100 megs and about 15 seconds on 500 megs. When I would process all the elements, the other extreme, the text, it roughly takes about two times as much. Also, there's a significant difference between deep skip and shallow skip. With deep skip, the processor can optimize the process because it doesn't have to do anything with the children. And with shallow skip, all the children have to be processed and have to be tested against matching templates. And that takes quite a lot of extra time.
Aren't those speeds the same as the previous graph? Can you just go back to the previous one? It looked like 15 was this.
This one?
For the red, go back one. Still 15, it's the same. It's not any faster, is it?
Sorry?
I don't quite understand that.
Oh, you mean why this is actually slower than the DOM approach? Yeah. It is. The main reason that it is slower is that we are still implementing this streaming. There's a lot of effort going on to implement the spec as it is. The performance optimization is not yet there. So these are real numbers. I did not fake them just for the sake of this talk. You also see that the numbers scale well. With DOM processing, you don't always have this nicely scaling graph as soon as memory is sparse, it doesn't really work anymore. But you just see that the 500 meg processing was 35 seconds. When I go to 5 gig, which didn't fit in my memory, I simply go to 350 seconds. So 10 times as large of an input is 10 times as long of a process. So, to summarize, we can now with XSLT3, we can combine streaming and in-memory processing. As you've pointed out, it's not yet as fast as in memory, but we'll get there. Hopefully we'll get it faster. And we've seen that XSLT3 brings great expressive power for lazy processing XML. You can filter and you can say like, I want that node, I want it as a DOM, and everything else I will just try just in a normal streaming way and process it that way. Thank you.
some questions? Yes?
Did you have, I mean, it's interesting to see the processing times, but really what a lot of us would be interested in is the memory size, you know, the how much of the stack you use, how much memory you actually use for that. Were you tracking that at all, or could you?
Yeah, I have been tracking that. In the DOM approach is like we are used to, like 3 times till 6 times as much as memory that you need, depending on the type of document that you're loading. With the streaming approach, I've seen constant memory. Actually, when I tested that with Saxon, I started out with 200 megs, and then during the process it became less and less. I'm not sure why that happened, and I ended up with 150. But there will probably be options to say, like, I want only that amount of memory to use, because the idea of streaming, as it is defined in XSLT, is to also be able to process it on low memory devices. You typically should not need any more memory than the current node and its ancestors and the attributes of that. Adam, sorry.
You said some functions have been added to XSLT3 for this, and there was copy of and ancestor. And ancestor keeps the ancestors and copy of discards them, right?
Snapshot, you mean?
Snapshot, thank you.
Yes.
Is that just an optimization? And if so, could that not just be solved with a single function and some static analysis?
It's with static analysis, you mean to have like a copy of.
Yeah, exactly.
If you try to reach the ancestors, that the processor will know that it has to take on the ancestors. It's not that easy to do that kind of static analysis, because you can go with free ranging all through the whole XSLT, or with worse, maybe in packages or imports and everything. So I think the reason was to do it this way is to give the programmer who knows his input and knows what he wants to use, to say, like, snapshot if it still wants to keep the ancestors, or a copy of. I have not tested actually the performance differences between those two, but I think the snapshot will be slightly slower.
I think basically the idea with snapshot is to give the developer the power to say, I want to stream the document, but for those and those bits, I know that won't be used, and I know that's not streamable regarding what I want to do. So I choose to not stream that bit. Okay, that's cool.
Wondering if you or anybody else has considered the use case of streaming between steps in XPlot.
Sorry, one more time.
I wonder if you've considered the use case of streaming between steps in XPlot. So 2 streaming XPlot steps streaming between each other.
You mean that instead of doing the first step at once and then doing the next step at once, to pipeline them directly?
There's nothing in the spec that disallows that scenario. It's just that your steps have to be streamable, and this is very easy to make. You know, it's not just about the processing; it's about the order of your data. If you have extreme order, you know, you want a different order from the data. You know, there's just some impossibilities as well.
And there's a research project which has written a streamable export processor, but not the entire spec, just a subset, and they're advancing that.
It's quick.
They've made good progress there.
I like the concept of this FN copy of for potentially performance reasons.
Mm-hmm.
So what I'm saying, if we were just living in the world of DOM, I know that'll probably come to XQuery and so on as well. For you to take a copy of this particular element, if we have DOM in memory, instead of reading all of the DOM from that point and then generating another document, you could just take a slice of that memory and just create a copy of that memory. And so there's plenty of times where I'm reading a document and I only want to return a part of it, but I don't want to have to force the process to generate or recreate that DOM thing. So I don't know. There must be room for performance improvements with this copy option in terms of just DOM stuff.
You might be right there. Well, all these functions that I showed you are specific for streaming. They are made for streaming, but any conformant processor must support these functions as well, even when it doesn't support streaming. So in the DOM scenario you're saying, app and copy will simply work, and of course it's up to the implementer of the process to make a specific optimization there.
Yeah. Sounds cool. Any more questions?
Go on.
Is there a party in Amsterdam? Would you like to Amsterdam?
Yeah, probably. Last time I put a slide on like that with dates, there was an XML Prague, and we didn't make the deadlines. But we will get there. So the next definite deadline will be July 22 for a private beta launch. Anybody interested can sign up, and they will get a copy to do some testing or playing around with it and give some feedback. Let's hope we also make the other dates.
Last question, Dino.
Yeah. Tell us more. What's it written in?
Sorry?
What's it written in? What does it do?
Excel is written in F#. It's meant for .NET. And I mean, Java people have Saxon, so I thought maybe .NET should have its own XSLT processor as well. I use F# because it's a functional language, which makes it slightly easier to map the functional languages XPath and XSLT.
What about doing it in Scala?
I can, that's Java, I can.
Yeah. Okay.
Can you cross-compile with Mono?
Can I what?
Can you cross-compile it with Mono if I want it on Java?
Yeah, it runs on Mono.
Excellent. Cool.
Okay.
Thanks everyone.